Alright guys, this little logic for timer is a bit extended one because it has more features or more bits for the timer. Over here, this Y naught is the timer enable bit and it will remain high until the timer is powered on. The next bit is the timer running bit. It will be on until the timer is like running in actual, like it's counting. So there are two things. The timer is powered, but the timer is not counting at that point, right? So it won't be on. So it would only be on when the timer is actually counting. The third is we call the timer done bit, which is when the timer value reaches the preset value which we has given over here, like 10 seconds. So as soon as that value is reached, eventually the timer running bit will turn off and the done bit will turn on. So in practical application, you will need to use a lot of these timer bits and use these contacts in your programming logic. Like when my timer is running, your output should be like conveyor should be moving or something. And when it's like completed, the gate should be closed. So these bits will help you eventually in a detailed ladder logic programming that you would do. All right, so just to briefly tell you that I have used a few memory locations like M0 over here, and I have latched this timer. My timer is over here, which is from again 0 to 10 seconds, and these are some of the bits. So this is the initial state. I will quickly run this timer by a push button. As soon as I turn it on, and if I turn it off as well, that's a push button, it's latched. So timer keeps on running. And you can see timer is enabled. That was the timer running bit, and as soon as it hit the 100 mark, done bit is active, right? So I'll just quickly reset everything and show the simulation again so that you can see it again. All right, so I'm turning my timer on, and you can see over here the timer is running. It's powered on, it's running, and this bit is not yet high. As soon as it hit the top mark, you can see the timer is not running, but the done bit is high, which means the timer has reached its counting part, right? It has completely counted. This bit is high because you know that the timer is still powered on, which is through the latching power. And this will only be turned off when we didn't provide the power to the timer. So if we didn't provide power to a timer, all of the bits will eventually go low. So in this example, we see that how you can manipulate three bits. One is whether my timer is powered or no. The second is like whether my timer is running, and the third one is whether my timer has reached its preset value or not. And secondly, you have tried to latch the timer so that with the push button, your timer starts and it keeps on running. Thank you so much.